Yeah, welcome back, my friends. You may still be remembering me. I am Professor K.K. Matthew from Bangalore, India. I had published a few chapters of my other courses like Python, Java, etc. in my YouTube channel. Maybe an year back, I think, my course on Java appeared. And maybe 2 years back, parts of my course on Python appeared. So, my courses are mainly available in the Udemy platform. I have done a lot of courses from C++, Python, Java, JavaScript, then Golang and Rust, etc. All these courses are very much available in the Udemy marketplace. That's okay, fine. Now, I am just now starting a course on Rust because Rust is the latest in software today. The Rust programming language has become the most popular and the most reliable programming language of today. It is heavily used in almost every field, and its usage is increasing day by day. More and more companies are coming to Rust and Rust related technology. So recently there was a news clip in Times of India, specifically speaking on April 12, 2023. There was a news clip in Times of India, one of the most popular dailies in India, that the programming language, why the programming language Rust is becoming so popular. The news clip titled, Why the Programming Language Rust is Becoming So Popular. I have included that news clip in my this course. In the immediately after this lecture, you can see that news clip also. Now, it all shows that the importance of Rust is now being recognized all through worldwide, all through the software industry. It is becoming the most popular programming language of today because it has come as a replacement for C++. The most versatile languages known as C and C++ has its own defects and its own drawbacks. When it comes to modern programming scenario, C and C++ has some basic drawbacks, like it's very difficult to manage memory properly in C and C++. It is equally difficult to manage multi-threading in C and C++. So safety and this concurrency has become great problem in C and C++. So as an alternative to that, Mozilla has invented this Rust language. The Rust programming language is actually highly safety oriented and it is very suitable for multi-threading. Lots of technologies which is not available in other languages is very much there available in the Rust programming language. It's a totally different language. The approach is totally different language because, for example, many of the popular languages today like Java, C++, or C Sharp, etc. See, they all have this garbage collection. It's a very prominent feature in all the modern programming language, garbage collection. But I'm telling you, in Rust, you don't have a concept of garbage collection at all. So, many of the idioms available in the Rust programming language is fundamentally different from the other popular programming languages. And its approach is again very different, very much different. So, it is very much suitable for safety and concurrency. That is the greatest slogans of Rust programming language. See, I will tell you, Rust, it started as a systems programming language. It is heavily used in systems programming languages. It can be equally used in, not only in operating system, device drivers of all sorts, then databases, file systems, then networking, then game development, and whatnot, cryptography and whatnot. In all these areas, Rust is now being used as the prominent language of choice. So, then, as I told you, why Rust came on earth? The main reason, as I already suggested, is the difficulty in managing memory with C/C++ language. That is one major point. Now, another is the difficulty in managing multi-threaded programming using C and C++. In these two areas, Rust is superb. See, we can say that, the three major aspects of Rust is safety, speed, and concurrency. Safety, speed, and concurrency. Now, another thing is that WebAssembly is now becoming very popular, It's a technology is of very much importance today. WebAssembly, WASM. And I am telling you, this Rust is very much suitable for WASM programming. In fact, I am doing a course on WASM. There I am actually using Rust. So the implications of Rust is that wide. It is that wide and varied. See, so you cannot think of as becoming a great software professional without having a deep knowledge in Rust. In today's environment, if you want to become competent in this highly complex software environment, you will have to study Rust seriously. I am telling you, you will have to study it very much with great importance. You have to study it seriously from the beginning. So actually this course, my course, I am not, see, it's already available in Udemy platform, but here I am now going to give you a free course, a complete course on Rust. See, this Rust program, this course is divided into 41 chapters. 41. In fact, you can say 41 parts. This is now what you are going to listen today is the first part. So totally this is a course divided into 41 chapters. So this is part 1 of 41 or chapter 1 of 41. So now look, see, you will have to study the thing from the beginning. I will be continuously publishing each chapter in a day within a gap of 1 or 2 days. And in another 1 or 1.5 months' time, I will completely come out with the full course. I hope this will be of great use to you and you will be able to enjoy this course. So thanks for watching and be prepared to have a serious, prolonged learning of Rust programming. Fine. Thank you very much. Rust programming, a total reference. This is Rust programming, a total reference. Fine. This course is developed by Professor Matthew K.K., a retired professor from the Department of Computer Science and Engineering, who worked in some of the most renowned engineering colleges in Bangalore, India, for over a period of 25 years plus. For over a period of 25 years plus. Yeah, part 1. Part 1. The author has published a number of other courses on C++, Python, Golang, and Java, etc. on the Udemy platform and is very much available on the Udemy marketplace. Full stop. This course is on Rust programming, which has emerged as an important systems programming language and is fast becoming the language of choice. For whom this course is most useful? Let us discuss for whom this course is most useful. If you are already a systems programmer, and you are ready for an alternative to C/C++ C++, this course is for you. Full stop. If you are an experienced developer in any programming language, comma, whether it is Java, comma, C Sharp, comma, Python, comma, JavaScript, or something else, this course is again for you. This course is again for you. Fine. Yeah, general introduction. General introduction. Rust is a language for systems programming. Rust is a language for systems programming. Full stop. Systems programming is employed in many areas like operating systems, comma, device drivers of all kinds, comma, file systems, comma, databases, comma, cryptography, comma, networking, and a plethora of other areas. Systems programming is highly resource constrained programming where every byte and every CPU cycle counts. See, where every byte and every CPU cycle counts. Full stop. Rust is a new systems programming language that combines the of performance and low-level control of C and C++ with memory safety and thread safety. That's it. Rust is a new systems programming language that combines the performance and low-level control of C and C++ with memory safety and thread safety. Let us see where systems programming is heavily used. See, let us just discuss where systems programming is heavily used. Yeah, areas where systems programming is used. We are discussing the areas where systems programming is used. One, operating systems. One, operating systems. Two, device drivers of all kinds. Device drivers of all kinds. Three, file systems. File systems. Four, databases. Databases. Four. Five, code that runs on very cheap devices, comma, or devices that must be extremely reliable. That's it. Code that runs on very cheap devices or devices that must be extremely reliable. Six, cryptography. Then seven, media codecs. Media codecs. That means software used for reading and writing video, comma, audio and image files. That's what is meant by media codecs. Okay, fine. Then eight, media processing. Media processing. For example, speech recognition or photo editing software. Speech recognition or photo editing software. Nine, memory management. Memory management. See, like implementing a garbage collector, etc. Like implementing a garbage collector, etc. Yeah, areas where systems programming is used, continued. We are continuing our discussions on the areas where systems programming is used. 10. Text rendering. 10th point is text rendering in bracket. Conversion of text and fonts into pixels. Conversion of text and fonts into pixels. 11. Implementing higher level programming languages like Python or JavaScript, etc. Implementing higher level programming languages like Python or JavaScript, etc. Next, networking, 12, networking, fine. 13, virtualization and software containers. Virtualization and software containers. 14, scientific simulations. Scientific simulations. 15, game implementation. Game implementation, fine. In short, there is no area which is free of systems programming concepts, comma, from database to networking. From database to networking. Fine. Yeah, why Rust? We are asking the question, why Rust? Look, a very serious question. In fact, a very serious question. There are so many powerful languages like C or C++, comma, or even of late Python, etc. See, there are so many powerful languages like C or C++, comma, or even of late Python, etc. Full stop. The answer is deep and much fundamental. The answer is deep and much fundamental. Full stop. Systems programming languages have come a long way in the past 50 years since we started using high-level languages for writing operating system programs. Since we started using high-level languages for writing operating system programs. Full stop. But two problems in particular have proven difficult to crack down. Two problems in particular have proven difficult to crack down. One, it is difficult to write secure code. See, it's very difficult to write secure code. Full stop. It is especially difficult to manage memory correctly in C and C++. Full stop. Programmers have been suffering with the consequences for decades in the form of security holes dating as back as the 1988 Morris wave. As back as the 1988 Morris wave. Full stop. Two, it's very difficult to write multi-threaded code, which is the only way to exploit the abilities of modern machines. In fact, that's the only way to exploit the abilities of the modern machines. Full stop. Even experienced programmers approach threaded code with caution. Threaded code with caution. Concurrency can introduce broad new classes of bugs which will be difficult to fix. Why Rust continued? The question why Rust we are again discussing. Look, Rust focuses on three goals. Rust focuses on three goals. One, safety, then speed and concurrency. What are the three goals? Safety, speed, and concurrency. The language was designed for developing highly reliable and fast software in a simple way. The language was designed for developing highly reliable and fast software in a simple way. Rust can be used to write high-level programs down to hardware specific programs. So we are again discussing that. See the 3 points we are elaborating. Like, look, performance. Rust programming language does not have a garbage collector in bracket GC by design. Rust programming language does not have a garbage collector or GC by design. Full stop. This improves the performance at runtime. Now next, memory safety at compile time. The next point is memory safety at compile time. Look, software built using Rust is safe from memory issues like dangling pointers, buffer overruns, and memory leaks, etc. Dangling pointers, buffer overruns, and memory leaks, etc. Fine. The last point is multi-threaded applications. Rust ownership and memory safety rules provide concurrency without data races. It provides concurrency without data races. Great. Support for WebAssembly. WASM. WASM. Support for WebAssembly. Look, WebAssembly helps to execute high computation intensive algorithms in the browser, on embedded devices, or anywhere else. Look, WebAssembly helps to execute high computation intensive algorithms in the browser, on embedded devices, or anywhere else. Full stop. It runs at the speed of native code. Rust can be compiled to WebAssembly for fast, reliable execution. reliable execution. Fine. Now look at Rust. Now look at Rust. Let us discuss Rust in detail. See, a safe, concurrent language with the performance of C and C++ put together. With the performance of C and C++ put together, full stop. Rust is a new systems programming language developed by Mozilla and a community of contributors. Full stop. Like C and C++, Rust gives developers fine control over the use of memory, and maintains a close relationship between the primitive operations of the language and those of the machines it runs on. Fine. To these, Rust adds its own goals of memory safety, and trustworthy concurrence. This is an important point. To these, Rust adds its own goals of memory safety, and trustworthy concurrency. Fine. The key to meeting all these promises is Rust's novel system of ownership, moves, and borrows, checked at compile time and carefully designed to complement Rust's flexible static type system. That's it. Rust's flexible static type system. Full stop. The ownership system establishes a clear lifetime for each value, making garbage collection unnecessary in the core language. That's it. Making garbage collection unnecessary in the core language, and enabling sound and flexible interfaces for managing other sorts of resources like sockets and file handles, full stop, Moves transfer values from one owner to another, and borrowing lets code use a value temporarily without affecting its ownership, full stop. These are all features programmers might not have encountered in the past. These are all features programmers might not have encountered in the past. Fine. Yeah, features of Rust continued. We are continuing our discussions on the features of Rust. These same ownership rules also form the foundation of Rust's trustworthy concurrency model. Rust trustworthy concurrency model, full stop. Rust can actually check at compile time that your code locks the mutex while it accesses the data. Full stop. Most languages admonish, that means caution. Most languages admonish. Admonish means caution. You to be sure not to use a data structure yourself, after you have given it to another thread. Full stop. Rust checks that you don't do that. Thus, Rust is able to prevent data races at compile time. That's the power of Rust. Thus, Rust is able to prevent data races at compile time. Next. Rust is not really an object-oriented language, although it has some object-oriented characteristics. Rust is not a functional language, although in its strict sense. Rust resembles C and C++ to an extent, but many idioms from those languages don't apply, So typical Rust code does not deeply resemble C or C++ code. So a typical Rust code does not deeply resemble C or C++ code. Yeah, features of Rust still continued. To get feedback on the design from real world settings, Mozilla has developed Servo, a new web server engine in Rust. A new web server engine in Rust. Its name is Servo. Look, Servo uses Rust safe concurrency to put the full machine to work on tasks that would be impractical to parallelize in C or C++. That would be impractical to parallelize in C or C++. Full stop. In fact, Servo and Rust have grown up together. In fact, Servo and Rust have grown up together, with Servo using the latest language features, and Rust evolving based on the feedbacks from Servo's developers, and Rust evolving based on the feedbacks from Servo's developers. Fine. Yeah, type safety. We are now discussing the concept of type safety. Rust is a type safe language. Rust is a type safe language. We say a language is type safe when programs written in that language does not exhibit any undefined behavior when it runs. Does not exhibit any undefined behavior when it runs. Full stop. Let us define some terms more explicitly. Let us define some terms more explicitly. If a program has been written so that no possible execution can exhibit undefined behavior, we say that the program is well defined. If a language's safety checks ensure that every program is well defined, we say that the language itself is type safe. We say that the language itself is type safe. Fine. A carefully written C or C++ program might be well defined, but C and C++ are not type safe. C and C++ are not type safe. The programs may not have type errors, yet it can exhibit undefined behavior. By contrast, Python is type safe. On the other hand, Python is type safe. Not that being type safe is independent of whether a language checks types at compile time or at runtime. C checks at compile time and is not type safe. But look, Python checks at runtime and is type safe. That's it. Python checks at runtime and is type safe. Type safety continued. We are continuing our discussions on type safety. It is ironic that the dominant systems programming languages C and C++ are not type safe, while most other languages are. In fact, most other languages are type safe, full stop. Given that C and C++ are meant to be used to implement the foundations of a system, type safety would seem like an especially valuable quality for them to have. It would have been a valuable quality for them to have. Next, this is the decades old tension Rust is trying to resolve. This is the decades old tension Rust is trying to resolve. It is both type safe and a systems programming language. Full stop. Rust is designed for implementing those fundamental system layers that require performance and fine-grained control over resources, yet still guarantees the basic level of predictability that type safety provides. That type safety provides. Yeah, type safety still continued. We are continuing our discussions on type safety. See, Rust's particular form of type safety has surprising consequences for multi-threaded programming. Full stop. Concurrency is notoriously difficult to use correctly in C and C++. Semicolon. Developers usually turn to concurrency only when single-threaded code has proven unable to achieve the performance they need. Full stop. But Rust guarantees that concurrent code is free of data races, comma, catching any misuse of mutexes or other synchronization primitives at compile time. Full stop. In Rust, you can use concurrency without worrying that you have made your code impossible for any but the most accomplished programmers to work on. Fine, full stop. Like those of other statically typed languages, Rust types can do much more than simply prevent undefined behavior. Full stop. An accomplished Rust programmer uses types to ensure values are used not just safely but meaningfully also, comma, in a way that is consistent with the application's intent. In a way that is consistent with the application's intent. Full stop. Obviously, Rust is a major step forward in systems programming. Obviously, Rust is a major step forward in systems programming. Fine.